The rule of 72 is this rule of thumb you can use to figure out what kind of interest rate a given investment needs to earn in order to double the money after so much time. It's based fundamentally off of these three different formula that we use when we're thinking about financial applications. A, the amount of money we want some investment to be worth, is equal to P, that is the principal that we start with, times 1 plus R, where R is the interest rate that we associate with that particular investment, raised to the T power, where T is how much time we leave the investment sitting there. In the real world, we also include this factor N. N is how often the investment compounds in a given year. If the investment is something as simple as a savings account at a bank, N might be 12, because the bank is going to put the interest you've earned into the account at the end of each month, and that's going to happen 12 times a year. Again, y'all, it's summer, we're going slow. Fundamentally, though, a business isn't really the kind of thing that grows in this punctuated sense. Instead, a business is the kind of thing that grows continuously, like a tree or a child. For continuous compounding, we use this version of the formula A equals PERT. P times e to the RT, where A, P, R, and T are all the same things they were before, but E is this special mathematical constant that pops up in all sorts of ways anytime we're doing stuff with exponents and anytime we're doing like limiting processes. For the rule of 72, here's what's important to us. We don't even want A in general. We are specifically interested in when will our money have doubled. So it's not A, it's actually 2P that we want P times e to the RT to be equal to. With some simple algebra here, you can actually divide out your principal from both sides, and we're really just looking at 2 equals e to the RT. Now, algebraically speaking, it's weird to have the R and the T up here in the exponent, so we want to find a way to bring them down. That is, we want to undo that e part of this equation right now, and the way we do that is with something called the natural log. We're going to take the natural logarithm on both sides of this equation. On the left, of course, it's just going to be the natural logarithm of 2. We'll have a calculator tell us what that is in a moment. But on the other side, quite beautifully, the natural logarithm and the e to something cancel each other out. And so it leaves us simply with rate times time. Now, if you go to a calculator, the natural logarithm of 2 is roughly 0.693, and here's where the rule of 72 comes back into play. Since we're already expecting our interest rate to be some percentage, then what we're going to do is kind of move the decimal twice on this 0.693, and it gives us this product. 69.3 should be equal to the rate, stated as a number rather than a percentage, times the amount of time. As you might imagine, the rule of 69.3 is not very catchy, and even more importantly, 69.3 is not very easy to divide by stuff. Whereas 72, on the other hand, is a very easy number to divide by stuff because it has a lot of different divisors. And now we're fully ready to use our rule of 72.